The goal for the warm-up is to use two different methods, the distance formula, which is this formula here, and then Pythagorean theorem, in order to find the distance between P and Q. So for the distance formula, the first thing you need to do is write the coordinates of P and the coordinates of Q. So if you look at P, starting at the origin, you would go 1 to the right and then up 4. So my coordinates would be 1, 4. To get to Q, starting at the origin, you would go 6 to the right and up 2, so 6, 2. The next thing you need to do is label your ordered pairs. In fact, here's an example of how you label them. So X comes first and then Y for every ordered pair, and since P was written first, it's going to get the 1s, the subscript of 1s. X comes first and then Y always, and then since Q is written second, it's going to get the 2s. From there, I'm going to set up the distance formula with nothing plugged in yet. So the big square root symbol, 2 parentheses with an addition sign in between them, minus signs inside, and then each parenthesis being squared. Then using a different color, I'm going to plug in the actual numbers. So let's look at the formula. X2, which is 6, X1, which is 1, Y2, which is 2, Y1, which is 4. So I'm going to rewrite that square root symbol, and now I'm just going to subtract my numbers inside the parentheses. So 6 minus 1 is 5, so 5 squared, plus 2 minus 4 is negative 2, so negative 2 squared. So 5 squared is 25, and then negative 2 squared is 4. You always get two positive numbers because you're squaring them. And then when we add these together, we get the square root of 29. So we're going to leave it as a root. So the second way that you could have found the distance between P and Q is using Pythagorean theorem. So Pythagorean theorem works for every right triangle. A and B are the legs, and then C is the hypotenuse. So the theorem is A squared plus B squared is equal to C squared. So I'm going to go back to this picture here and recreate a right triangle. So this is A, this is B, and the hypotenuse is C. So if I plug in for my picture then, A, if you count how many boxes across A is, counting across, 5, so 5 squared, plus B is 2, so 2 squared, and I'm trying to find the hypotenuse, which we know our answer must be the square root of 29, because we already found that using distance formula. So 5 squared is 25, 2 squared is 4, and that's equal to C squared. So 25 plus 4 is 29, and that's equal to C squared. And the last step to undo a power of 2, the opposite of squaring, is square rooting. So we got the exact same answer. The hypotenuse is the square root of 29. So if you look at the connection between Pythagorean theorem and distance formula, you should notice that technically these are exactly the same thing. So how did we get A, which was 5? We just subtract the x coordinates, right? 6 minus 1. How did we get B, which is 2? You subtract the y coordinates. Technically, we just counted the boxes, or 4 minus 2. And then the very last step, we took the square root in order to get C alone, which is why the distance formula has a big square root symbol. So the goal for the notes is to derive the equation of a circle, which comes from the Pythagorean theorem, a squared plus b squared equals c squared. And just like the warm-up, where the Pythagorean theorem looked different in the form of the distance formula, we're going to be rewriting this theorem using different letters. So in this picture, we have a circle, and we're asked to label a couple of things here. So it says label the center h, k. So instead of actually labeling it 4, 3, the center right here, we're going to use generic variables. So the center is h, k. Then we're going to be connecting a radius, call it r. So the radius goes from the center to a point on the circle. So here's our radius, r. And it says to call that point that you connected here, x, y. Now that we have this labeled, since Pythagorean theorem only works for right triangles, we have to create a right triangle from this picture. So I'm going to connect here and here to create a right triangle. This would be my side length A. I'm choosing that to be the A. this the b, and I'm going to leave r the radius, which is my hypotenuse of my right triangle. So I'm just going to leave it as an r there. So essentially what we're doing is we're taking this equation, a squared plus b squared equals c squared, and we're going to replace a, b, and c with letters from this picture. So for a, how would I get a? In this picture, technically I would count the units across to get a, but in this case, we're going to be using generic letters. So I'm going to draw some lines down to represent the two numbers that I would subtract, but instead of using numerical values, we're going to be using the letters from this picture. So what is the value here? Well, this would be x units across, and then what's the value here? This would be h units across. So in fact, in order to rewrite a, I would take x and subtract h from it. So how do I get b? Well, I would have to take this number here and subtract this number. So this top number is y, and the bottom number is k. So if I plug this in, it would be y minus k squared. And that's equal to, what is the hypotenuse? Instead of c, we're going to use r. So r squared. So in fact, this is the equation of a circle. It's just the Pythagorean theorem rewritten using different letters. So x minus h squared plus y minus k squared equals r squared. And then h and k, that was the center of the circle, right? And r is the radius. So for these next few examples, our goal is to write the equation of the circle. So technically, we're going to be plugging in a number for h and k, which is the center, and a number for r, which is the radius. So if I look at this, my center is 5, 3. So this is my h and this is my k. And then the radius is 2. So if I look at my formula, it goes x minus h, which is 5, squared, plus y minus k, which is 3, squared. And then I'm supposed to plug in the radius and square it, so 2 squared would be 4. One thing you'll notice is that if the center had positive values, there will be negatives inside the parentheses. And vice versa, if the center has negative values, when you plug it in, you would have a double negative and they would turn positive. So for part B, my center, -2, -11 is my HK. And in this case, they gave me the diameter. Remember, the diameter goes all the way across. So if all the way across is 18, how could I get the radius? That would just be halfway across, would be 9. So I'm ready to plug this in. So I would have x. So I'm plugging in a -2. The formula already has a minus sign, so if you have double negatives, it turns to a +2. So x plus 2 squared plus y, again, a double negative would turn it to a +11. So y plus 11 squared, and that's equal to, I'm supposed to take 9 and square it. So 9 times 9 would be 81. All right, for part C, my center is -4, 0, so this is my h comma k, and the radius is the square root of 47. So plugging this in, x, remember if it's a minus sign that you're plugging it in, you would plug in the opposite sign because you would have a double negative, so x plus 4 squared plus y. And if you ever have a 0 that you're plugging in, it doesn't matter if you write -0 or +0. In fact, if you ever have a 0 as a coordinate, all you would do is write y squared, because it's the same thing as y plus 0 squared or y minus 0 squared. And that's equal to, so from here, I'm supposed to take the radius and square it. So if you take the square root of 47 and multiply it by itself, Remember, root times itself gets you back to the radicand, the whole number, so it's just 47. For part D, we're doing the opposite. We're given the equation and we're supposed to write the center and then the radius. So remember how the signs flip. So if this is a minus sign, your center had to have had a first coordinate that was positive, and if this is a plus sign, your second coordinate had to have been a negative to get that double negative. So you just flip the signs when you pull out the coordinates, and then you flip the signs when you plug them back in. And then remember, this number on the right-hand side, it's equal to r squared. So what can you multiply by itself to get 16? Or in other words, if you take the square root of both sides to solve for r, the square root of 16 is 4. So the radius is 4. For this next one, we're given the graph and we have to write the equation. So there's two things we need. We need the center and then we need the radius. So the center, how do I write this point as an ordered pair? From the origin, I go 1 to the left, so that would be -1, and then I go up 2, so +2. All right, and then the radius. So remember, to get a radius, you have to go from the center to a point on the circle. So I would suggest either using a horizontal or a vertical line. Nothing that would be diagonal like this because you can't count the boxes. So if I use this horizontal piece, I'm just going to count the units across. 1, 2, 3, 4, 5, 6. So the radius is 6. So I'm ready to write the equation of the circle. So I would have x, take this and flip the sign, right? Because this is my h comma k. So this becomes a +1 squared plus y. +2 becomes a -2 when you plug it in, squared, and that's equal to, we have to square the radius. So 6 times 6, 36. For these last two, we're going to be graphing the circles. So in order to graph them, same two things you need, the center and the radius. So the center, all you're doing is taking these numbers here and flipping the signs, right? So +3, -1. And then the radius, remember, the equation is equal to r squared. So again, r squared is 4. What can you multiply by itself to get 4? Or in other words, take the square root of both sides to get r alone, and that would be 2. So the radius is 2. So the first thing I'm going to plot is the center. So I'm going from the origin, 3 to the right. So 3 to the right and then down 1. So here's my center. Then from there, I need to use a radius of 2 units. So from the center, I'm going to count 2 to the right, this way, 2 to the right. So here's 2 to the right. I'm going to go back to the center, and then I'm going to count 2 to the left, which is right here. Back to the center, I'm going to count 2 up, back to the center, and then count 2 down. So if you draw 4 more points like we did here, that would make a pretty decent circle in order to connect. So there's my circle. So again, from the center, I went up 2, down 2, to the left 2, and to the right 2. For this next one, the center, if I pull out the coordinates, again, I just flip these signs. So the center is -2, -4. And then again, I know that this is the radius squared. So what can you multiply by itself to get 16? Or if you solve this by taking the square root of both sides, the square root of 16 is 4. So the radius is 4. So from here, I'm going to plot the center. So I go from the origin, 2 to the left and 4 down. So right here is the center. And then from there, I plot the radius. So from the center, I'm going up 4. So here's up 4, down 4. From the center to the right 4, and from the center to the left 4. So this would be my complete circle.